Hello and welcome back. First of all, I would like to thank you for supporting me in doing this good job. I want you to know that I always try to bring accurate and clear information to you. The sole purpose of me creating these videos is to help you understand those concepts that you always wanted to learn. At the end of this video, if you find it helpful, please do like, comment and share. If you are new to this channel, also hit the subscribe button in right bottom corner. With that being said, let's see what we have got today. So if on your ASA you see that your tunnel is staying at wait message 5, after once you complete this video, you will have enough reasons to figure out what could be the problem. To demonstrate, we're going to use this topology where we have two sites. One I've named as Cisco and the site as IBM, and they have VPN between them. So that VPN connectivity, VPN has been configured on these ASAs. This has been named as ASA1, and this device here, so this has been named as ASA2. There is a VPN between these two ASAs. Let's go back to the CLI. So I have already done a setup. I'm going to ping 192.168.10.1 from 10.10.1.1 and it will be a continuous ping. This ping is timing out, that means it's not working. Let's go to the ASA1 and see the status of the tunnel. Show crypto ICM SA. Well, it's not showing any status here. That means, okay, so it says wait message 4. The initiator is staying at wait message 4. What does that mean? wait message 4. Why will the initiator stay at wait message 4? We have already done a video on wait message 4 problems. So by this time, if you have not seen the video, go back to the previous video and understand why why the ASA will stay at wait message 4. I'm really not seeing any wait state here, and that's probably because it's happening very fast. So we could just do debugs and see what's happening. But before we do that, let's go to the ASA2 and check the status here. Show crypto ICM SA, and there you see. So this guy says wait message 5, and there are too many. You see, it's trying to create too many tunnels with the same peer IP, and the status is wait message 5. Now let's do some debugs to get into some details. So that's how I'll do a debug. Debug crypto condition peer and peer IP, which is 67.1.13.142, and then I say debug crypto ICM 128. Okay, there they are. I'll just do undebug all, and if you look at this debugs, may or may not get, so here it says received an unencrypted invalid cookie notify message dropping, and then says information exchange process failed. Now, of course, it doesn't tell us much about what, what's actually missing, or does it? So if you see here, scroll the debugs a little bit down, it says wait message 5 event problem auth fail send message 4. So it's sending message 4. So it doesn't look like there's any problem here. Otherwise, it will say that in the debugs. So we will have to go to the initiator and do the debugs. We have already done debugs on ASA2 and we did not find anything that can direct us. What we saw is that the responder is waiting for message 5. It says wait message 5. On the initiator, let's do some debug. So debug crypto condition peer and the peer IP, and then I say debug crypto ICM 128. That should get us enough information. Undebug all, and you can clearly see it says cannot find a valid tunnel group aborting. That means this ASA does not have a valid tunnel group, and that's why it's not sending message 5. This ASA2 says I'm waiting for message 5. The initiator is missing a tunnel group. So let's just configure a tunnel group and see what happens. First, let's see if it's really missing a tunnel group. Show run tunnel group, and it looks like yes, it is missing a tunnel group with peer IP 2.2.2.2. So I'm just going to say tunnel group type IPSEC L2L. Once we configure the tunnel group, we will also need to configure appreciate key, which is in the IPSEC attributes of tunnel group. IP1 appreciate key. I give pre-shared key as 12345. So see if the ping is working. It's not. Come back here. Show crypto ISIC embassy. This guy says I'm waiting for message 6 now. The responder is still at wait message 5. Wait a second, isn't that confusing? The initiator says I'm waiting for message 6. Responder says I'm waiting for message 5. So it's like initiator, responder. Initiator has sent first packet, responder has sent second, initiator sends third, responder sends fourth, initiator sends fifth message, and then it goes into a state wait message 6. The responder, after sending message 4, because if you remember, if we go to the responder, you see it's waiting for message 5. When will it wait for message 5? After sending message 4. The initiator says I'm waiting for message 6. Responder says I'm waiting for message 5. How is it possible? A responder has sent fourth packet and it went into a state wait message 5. The initiator has sent message 5 and that's why it's saying I'm waiting for message 6. If the initiator has sent message 5, the responder should not be at this state. It should not wait for message 5 because initiator has already sent it. Maybe message 5 did not reach here. Go to ASA2 and do some debugs. Debug crypto condition peer IP is 67.1.13.142. Debug crypto ICAM 128. Let's wait for the debugs. I'll just say undebug all. Think you can already see it. It says error, had problems decrypting the packet, probably due to mismatched pre-shared key aborting. Why does it say had problems decrypting the packet? Where did encryption come in? I mean, who encrypted it? And why do you have to decrypt it? To understand that, you have to go back to my previous videos and understand what parameters are shared in each packet. Then you will know why it talks about decrypting the packet. So I'll try to give a little bit information about that. Initiator, responder, after sending 4 packets, 1, 2, after sending these 4 packets, now both initiator and responder, they do some calculation. The calculation is to generate session keys. They both generate session keys independently. To generate session keys, first of all, they calculate Diffie-Hellman shared secret, right? And then they generate the session keys. In those session keys, they generate 3 keys: session key D, A, and E. Right? SKID D, A, and E. This SKID E, they both use that session key ID to encrypt the payload, not the complete packet, but the payload, some part of that packet. So this session key E is used to encrypt some part of message 5 and 6. So now when initiator is going to send message 5, it is going to send that message encrypted using session key E. In fifth packet, what parameters are sent? If you don't know the answer to that, you should pause this video right here and go back to the previous video where I've explained what information is exchanged in message 5 and 6. The link is given here on the top. In fifth packet, it sends 2 main parameters. One is the hash payload and the other one is identity payload. These 2 parameters are sent in fifth packet. The hash payload contains hash of the pre-shared key. It does not contain the pre-shared key, it just has the hash of the pre-shared key. And the identity payload will have the identity of the initiator, which means the IP address of the interface where cryptomap has been enabled to identify, to make sure that the communication is happening between the correct peer IPs. So because these two are crucial information, if anyone get to know what is the pre-shared key or hash of the pre-shared key, we don't want to get our VPN into trouble. So using session key E, it encrypts these 2 payloads and then sends the data to responder. Because they did that calculation, these session keys were generated using various parameters, which also includes pre-shared key. Pre-shared key is something that is already configured on both the devices and it has to be same. So let's say pre-shared key on initiator end is 1234, and responder end is also 1234. If the pre-shared key is same, right, then only this session key will turn out to be same. So if session keys are same, because it encrypts the fifth packet using session key E, that can only be decrypted using the same key, right? So if the responder has same pre-shared key configured, it will also generate the same session key. So once the responder receives fifth packet, it will try to decrypt it first, because that some part of that packet was encrypted, right? So the responder has to decrypt it first. When the responder decrypts it, it uses this session key that it generated here. In our case, in the debugs, you could see the error message that talks about error had problems decrypting the packet. It could not decrypt the packet, probably due to mismatched appreciate key, and it has given a probable reason that your appreciate key might be a mismatch. That's why I had a problem decrypting it. So it received fifth packet that was sent by the initiator, where initiator was, you know, telling every time I have sent the fifth packet and I'm waiting for sixth. So if initiator has sent fifth packet, responder has received it, but it could not decrypt it because it thinks that there might be a mismatch in the appreciate key. So how do we confirm that they have same appreciate key now? Where do we configure the appreciate key? In the tunnel group. So let's say show run tunnel group 2.2.2. So I can see there is appreciate key configured, but it's all stars. That means this is encrypted. The appreciate key cannot be seen. Let's see here. Show run tunnel group. We also have the appreciate key configured here, but it also says stars. How do we figure out what is the appreciate key configured? You can do that by this command: more system running config pipe begin tunnel hyphen group and the IP address of the peer. And you can see here IPv1 appreciate key 12345. So ASA1 has the appreciate key as 12345. Let's check the same thing on ASA2. So more system running config pipe begin tunnel hyphen group. You have to type this begin tunnel group. It won't take the tab and then the peer IP. So ASA2 has appreciate key configured as Cisco. ASA1 has appreciate key as 12345. So they both are different. So which one do you want to correct? You can correct any one. If you think you need Cisco, just change it on ASA1. So I'm just going to change it on ASA1. Go to tunnel group 2.2.2 IPSEC attributes and IPv1 appreciate key Cisco. The ping is already working. That means the tunnel came up. So in this case, you have also seen how to fix mmwait message 6, because if you remember on ASA1 we were getting mmwait message 6, right? That means there's a mismatch in the appreciate key. And if you're looking at ASA2, ASA2 was staying at mmwait message 5, because even if it received message 5, it was not able to decrypt it because of the appreciate key. So far we have found two reasons that the ASA will stay at mmwait message 5, and those two reasons are why the responder will stay at mmwait message 5. One, the initiator is missing a tunnel group. So like we saw earlier that the initiator was missing a tunnel group, and once we configured that, well, we were again at if the initiator is missing a tunnel group, you will have to configure the tunnel group along with the appreciate key. And the another reason was if the initiator has a tunnel group configured, then there might be a problem with the appreciate key. The appreciate key is a mismatch. And you have also seen that how do we check if the correct appreciate key has been configured or not. So these are the two reasons that the responder will stay at mmwait message 5. There can be one more reason, but I won't tell you just now. If you are watching my videos regularly and if they are helping you, then I want you to think what can be that one more reason that the responder will stay at mmwait message 5. You have to think of that reason and let me know via comments. So for this one, when the initiator is missing a tunnel group, we were able to see the debugs. The initiator was missing tunnel group and it was clearly saying can't find a valid tunnel group, aborting. In that situation, we created a tunnel group. And once there was a mismatch in the appreciate key, we were able to figure that out using the debugs, where it clearly said error had problems decrypting packet, probably due to mismatched appreciate key. So in this situation, the ASA1 or the initiator was stuck at mmwait message 6. That means it had sent the fifth packet but did not receive the sixth message. So in this video we have covered both mmwait message 5 and mmwait message 6. So why the initiator will stay at mmwait message 6 state? So for the initiator to stay at mmwait message 6, there are two reasons. One is mismatch in the appreciate key, which we have already seen, When there is a mismatch in pre-shared key, the initiator will stay at wait message 6 and the responder will stay at wait message 5. There is also one more reason, that if there is a mismatch in identity, you remember that in message 5 and in message 5 and 6 they share identity, right? In message 5 the initiator sends the identity payload. If there is a problem with the identity of the device, then also it will stay at wait message 6. Within Cisco, if both the devices are Cisco, then whatever identity you configure, there won't be any problem. They will automatically detect it. But it usually causes the problem with other vendors. The identity possibilities here, that what identities can be used, you can check that here. What you have to do is show run all pipe include identity. You should see crypto IPSEC identity auto. So it's set to auto. You can change that according to the requirement of the peer device. Crypto IPSEC identity, and the options are you can use address. You can just type the IP address. You can also do host name. If the remote end is fully resolvable, it's using FQDN, you can use that. You can also use key ID. So it totally depends upon the vendor. In this video we have covered both wait message 5 and message 6, how to fix them, and I've left one problem for you to fix, or for you to think, that what can be one more reason that the responder will stay at wait message 5. That's all for now. I hope this has been informative to you, and I would like to thank you for watching it. It is your support, your likes, comments that keep me motivated for bringing up more stuff like this. Please let me know if this has helped you. If you are new to this channel, also hit the subscribe button in right